Alright, we are on section 2.3 and it's called subsets of planes. And we do have these concepts that are building on each other. And I hope that gets in focus. But our last section that we talked about, we were talking about subsets of lines. And so if you remember, we're just talking about, parts of planes and parts of lines. So let me just do a little review. We had a line, and we had the line separation postulate that was saying that that any point will break a line into three disjoint sets, which means they don't have any parts in common. The point itself and then two half lines. So let me figure out where this is in focus. So we're going to build it up to the subsets of planes here. And so instead of lines, we're talking about planes. And the idea here is that if you have a plane, a line could cut through your plane. And what it would do is it would break your plane into three parts. So I'll just kind of do it right here. You would have the line, this half of the plane, that half of the plane. I'll just put like a little dot here. Okay, so a line could break a plane into three disjoint sets. It would be the line itself and two half planes. Same over here, the point itself and two half lines. So it's just the concept taken and applied to the next dimension. So that brings us to a lot of definitions that we have. And the definition that you have on page 49 says a half plane is a subset, so a part of a plane that consists of all the points. You should know that a plane is just a thin blanket of so many points that it creates a surface. So the definition of a half plane is all the points on the given side, okay, of a given line. So you have to specify which line, and then it's all the points that are on a certain side of that. The edge of the half plane is just the line itself. It's also known as the edge. And then we have opposite half planes. It says those are the two half planes that are separated by a particular line. So this is probably just intuitive. These two half planes are opposite. And the way that you would know they're opposite is if you took a point from this plane, call it A, and any point in this one, call it B. If you connected them, you would cross your edge. That's how you know that you are in a half plane, or opposite half planes. Let me see if I can get this in better focus. Hang on. Alright, the next definitions the next set of definitions we see in section 2.3 are going to go with angles. So we have angles. Angles are subsets of planes. So remember, we're just trying to talk about portions of planes. And it says, by definition, an angle is the union of two distinct rays with a common endpoint. Let me just draw a plane out here. So if I have two distinct, which means different ones, distinct rays, if they have a common endpoint, then you have formed an angle. The sides of an angle are the two rays that form the angle. So this would be considered a side. This one is the other side. Vertex of an angle is this point right here. It's the common endpoint. Sometimes it's also called origin. So let's talk about the notation that we'll use for angles. So generally a ray has 2 points, right? So we'll call this B and A. So cover that one up, and you can see you have ray BA. You can see that this would be called ray BC. So an angle is the union of 2 rays, specifically with a common endpoint. So that's the definition of your angle. Now, how you label an angle notation-wise is, for this one, it would be angle ABC. So this is how it works. This middle one is always the vertex. Now after that, this could also be called CBA, as long as B is in the middle. So you have that. There's a third way of writing it. You could call it angle B. So just the vertex. You are only allowed to do angle B, angle by the vertex, if there's no possible way you could confuse that with another picture. So for example, I'll do it right here. Okay. Let's put angle or point X. How about X? A, B, C, and D. All right. In this case, if I mentioned, hey, take a look at angle X. Angle X. You would look at that and you have 4 options to choose from. So you're not going to be able to call that one just angle X. So if I'm trying to talk about this angle in here, so this ray and this ray, I would have to call it angle BXC. Or you could have done it in reverse, or angle CXB. And that would have, all these two right here would have described this angle right here. So that's what's happening there. The next thing that we'll talk about is interior of an angle and exterior of an angle. It's just like it sounds. Interior is the inside of the angle. So if you do have to imagine, every time a ray isn't shown going to infinity, you have to picture it going to infinity. And so any point that is inside of here, just by the picture, I think you'd know what it means. This is going to be the interior of the angle. All right, and then what that does is it puts all of these points that you would find outside of this line and this line, it puts these on the exterior. So that's what you have for interior and exterior. The definition is going to explain it a little bit differently, and that's okay. So what it would do, let me put a bigger thing here. What the definition says, that imagine that this line right here is broken into a half, breaks the plane into 2 halves, this side and this side. And then what you do is you take this side, all right, you just specify that one. Then you take and start over and take your plane and you break it into 2 with this one, and then you shade this side. So what you should be able to notice is that the part that was in between these two, that's on the interior, it got shaded twice. So that's how they're trying to describe the interior. Okay, the definition of the interior right here says the interior of an angle is the intersection. So remember, an intersection means what they have in common. The intersection of the 2 half planes, each determined by a side of the angle and containing the other side. Okay. So it just meant what did these 2 half planes have in common? So what was part of both of them? So when I did, this this line right here, I had a half plane up here and a half plane down here. That was using one side of the angle. And if I use the other side of the angle this way, so I have a left and a right. So what was in common with both of those different ways that I broke up the half plane? It was the one that got shaded twice. That was part of both of them. So that's how you say it's the interior. So just so you know, the interior is all the points that are inside. You cannot include the lines themselves or the rays themselves, because the ray is the ray. It's not going to be part of the inside or part of the outside. It's not part of the interior or exterior. And that's going to include your vertex also. That's not part of interior or exterior. So I think you guys will understand it better by, inside and outside. But there is a formal definition, and you will need to know that. So what it says about the exterior of the angle is just the complement of the union of the angle and its interior. So remember what complement means again, but let's take the interior and the angle itself. If we union those together, then what is the complement, or what is left? And it would be all the points out here. So that's the definition of the exterior. They have a picture right here for your homework that you're going to have to use. So you're not ever going to be able to call this angle F. You're going to have to be specifying it by other points also. But it's a relatively easy section. Let me know if you have any questions. And our assignment in 2.3, 1 through 30. All right.